Hello friends, welcome to my YouTube channel. This is part 2 of digital system and application paper solution of physics 2020, right? It was held in 2021, but the semester started 2020 in 2020. Third sem, BSc third sem physics honors, Dibrugarh University question paper. So we have already solved the question, 1 marks question, the multiple choice question in the first part. Link is given in the description box. So before we start, please subscribe the channel, stay connected, and if you like my videos, hit the thumbs up button. Also share with your friends, and don't forget to hit the bell icon. Okay, always hit the bell icon so that you get notified when new video will be uploaded, right? When the next part will be uploaded. Okay, so now let's start. So we're going to start from question number 2, as we have already solved question number 1 in the first part. Link given in the description box, so you may go through. So define deflection sensitivity of a CRT. Obtain an expression for the deflection sensitivity of the electrostatic type. So here is the answer. This is not completed yet. This is the next page. Here this is the required expression. So now let me go to the definition here. Deflection sensitivity of a CRT is defined as the deflection on the fluorescent screen. Okay, if the deflection is given by D, so here is the diagram I have written Y. Suppose here, let me take Y is equal to D. Suppose the per volt of the deflecting voltage VD. Okay, if the deflecting voltage across these two plates I have applied is suppose VD, then the sensitivity is given by S is equal to D by VD. Okay, this expression. Okay, so now we have considered that this is the electron beam. Okay, this is the electron beam enters between these two plates. Okay, and you know these two plates are called deflecting plates. Okay, deflection plates, and one is positively charged. This upper plate is positively charged and lower part is negatively charged. Okay, so and the gap between these two plates are separated by a distance small d. Okay, by small d. Small d is the distance between these two plates, right? So hope you have understood this. So now when one electron enters and it goes between these two plates, right? So this negatively charged plate will deflect it in this way, right? And it is entering with the velocity, suppose u is the initial velocity with which it is entering between the plates. Okay, in the electric field, and length of these two plates be L. Let me take L. Okay, and if we extend this track, then it makes an angle theta with the x-axis. Suppose this is the x-axis, it makes an angle theta, the x-axis, and this point where this extended line, the line when it is extended backward, it intersect at a point which is, suppose, you know, this part is suppose L by 2. Okay, so that means at the midpoint of this region. Okay, so this part is L by 2, this part is L by 2, right? This length is L by 2. We have taken L by 2. Let me write it properly. Now you see or you can write here, this length is L by 2, right? L by 2. Okay, so now you see, and from this point the distance to the screen is suppose S, right? And and the velocity must have two components. This is Vx and this is Vy at this instant, suppose. Okay. So now you see the period during which the electron remains in the region between the two plates, right? And that means here you see between these two deflecting plates, positive and negative plates. Okay. So time taken or time period, okay, in which this electron is in between these two plates. Okay, from the that means time taken to reach this point from this point. Okay, from this point to this point, the time period during which it will be traveling between these two plates. Be suppose we have taken capital T. Okay, now you see if the length is L, if this length is L, length of its plate is suppose L, right? Length of this plate suppose L, and it is moving with velocity u, it is moving with velocity u, then the time period will be given by L by u, right? L by u. Okay, so now you see initial velocity along y-axis. Now you see this electron, it has velocity along horizontal direction along x-axis. Okay, so from this point, from this midpoint only, it is deviated, right? So from here it will have two components, x and y. Okay, its velocity will have two components, but before reach the point, this electron has only one point. It is entering with initial velocity u along x direction, and it has no velocity component along y direction. That's why uy is equal to 0. Here we have taken uy is equal to 0. Okay, so an acceleration along y-axis due to the electric field between these two plates will be given by qe. This is qe by m, where m is the mass of the electron. Okay, qe by m. So let me write it properly. Okay, so qe by m. So this is gonna be qe by m. Let me write here qe by m, where e is the electric field and m is the mass of the electron. Okay, and here the q is the charge of the electron. You can replace the q by e as well. Okay, if you want to replace. Okay, q is the charge of electron, and here you see e is the electric field. Electric field E is the electric field, and m is the mass of electron. Mass of electron. Let me write here. M is the mass of electron. Mass of electron. Okay. So that is what we have done. And if the potential difference here, you see, let me draw it here. Here you can see. So these are the two plates. Suppose these are the two plates. This is positively charged and this is negatively charged. And if these two plates are separated by a distance small d, and the potential across these two plates is suppose Vd, in that case the electric field E is given by Vd by d, right? And we have used this relation here. Okay, instead of this E, we have put this value. Okay, so we have got q by m cross Vd by d. So this is what we have got. This is q by m. Let me write it properly. This is q by m. Okay, and the velocity Vy along y direction after time t. So here we have used this formula, V is equal to u plus at, right? So for along y direction, that's why we're going to write Vy uy ay, and if I have taken the time taken to time taken to reach this end from this end by the electron of this series. When electron enters these two plates, between these plates, from this point to that point, it takes suppose capital T time. Then we're going to replace this capital T by small t by capital T, and here you see uy is 0. I have already mentioned here uy is already 0 because initially along y-axis there was no velocity, so uy is 0, this part is 0, so hence our equation becomes this. Okay, and acceleration ay, we have already got that ay is equal to this. Acceleration ay is equal to this is the expression of the acceleration, right? Here you can see this is the ay, right? So we have used this value of ay here, and doing so we have got this expression. Okay, so what we have got q by m. Let me write it properly. We have got q by m into vd by d into, and this t time is replaced by this expression L by U, right? L by U. Okay, so we have got this is equal to nothing but our Vy. Okay, so now let me go to the next slide. Now you see from this diagram, let me go to the next slide here. Let me draw it again. This is the x-axis, suppose this is the x-axis, and these are the two plates. This is positively charged plate and this is negatively charged plate, and this length is L by 2, this portion is L by 2, right? L by 2, and the total length is L. So that's how this electron is deflected, and this is the screen, suppose, and this part is suppose Y. So now here you see from this point to this screen is distance is S, right? So we can say this distance is also S. So now this angle we have taken theta, so from this triangle, this is the triangle we have taken, then we can take also two velocity component, this is Vx, this is Vy, right? So this angle will be also theta, right? This angle will be also theta. So we can by parallel shifting, we can do parallel shifting of vectors. This is Vx, so Vy can be taken here, right? So here you see this is the Vx, this is the Vy, and this is the vector V, and this is theta. Then this Vy by parallel shifting can be drawn here to obtain this triangle, right? And from both the triangle we can get tan theta is equal to from this triangle what we will get Vy by Vx, and from this triangle we will get tan theta is equal to y by s simply, right? So here just erase this. Okay, so here you see this is also tan theta, this is also tan theta, so Vy by Vx can be written as y by s because both is equal to tan theta, right? So Vx, we know the horizontal velocity was given u, right? So I have written u here. Then Vy we have got the vertical component of the velocity, we have got this in the previous slide. This is the expression. Here you see this is the expression of Vy we have already got here. So we have used these values, and you see if electron is being accelerated, okay, and to accelerate this electron, the velocity, the accelerating velocity is sorry, not velocity, accelerating potential is suppose VA. The accelerating potential is applied is suppose VA, and the charge of the electron is, we have taken Q here. So in that case, the kinetic energy half mu square, it is as it is moving with u, half mu square will be given by Q into VA, where V is the accelerating voltage. Okay, so we can write UA is the accelerating voltage. So just wait. Accelerating potential, you can say. Okay, so now you see accelerating potential. Now from this expression we get u square is equal to 2q VA by m. So we have got it. So now this value of u square is put here. Now putting this value of u square here, we have got this expression, right? Let me clean these things first. Just wait. So let me clean this first. Okay, now you see, so this is equation number, suppose. So now let me go to the previous slide. Here you see, let me take, this is equation number 1, and let me write here using 1. Okay, using 1, and you can pause the video and you can take a screenshot. So let me write this equation clearly. Just wait. So let me rewrite this equation clearly. Vy is equal to uy plus ayt. So on putting those values of uy is 0 plus ay, we have got ay is equal to this. Okay, use this value ay, and capital T, this is capital T, small t. So we have considered time is equal to this, t is capital T. So let me use capital T here, and so we have put u is equal to 0, then put the value of ay. This is the value of ay. Here you have got, this is the value of ay, right? Ay. So use here, and doing so we have got Vy is equal to this. This is the Vy, right? Okay, so let me take, this is equation number 2. This is equation number 2. Okay, so I have taken this as equation number 2. Let me go to the next slide. So this is suppose equation number 3, and here you can write here. So this Vy is replaced by this result, and this is obtained from this equation number 2. From this equation number 2, so you can write from 2. And let me draw the triangles that I have used to obtain the tan theta. Those are the triangles. This is theta, and this component was Vx, and this was Vy, and also we have used this y by s. This is theta, right? From this diagram you can say this is y, and this is by s, y by s, this is s, right? And similarly this Vy can be drawn here by parallel shifting, so this angle will be theta. So from here we have got this triangle Vx, this is Vy, this is theta, right? So from these two we have obtained tan theta. Okay, so this is equation number, suppose 4. So here we will write that here we're gonna write that using 4 in 3 we get. So this is question number 3. What is monolithic IC? So this is nothing but it is a group of circuits manufactured over a single semiconductor plate, mostly in silicon plate. Okay, so that is the definition of this monolithic IC. Okay, now let me explain the steps involved in fabricating a diode in an IC. Okay, so these are the steps involved in fabrication of diode in an IC. Okay, these are the steps. So here you see, first step is to take a p-type substrate. Let me take a p-type substrate here. This is a p-type substrate. Suppose this is p-type substrate. Then over it we have deposited n-type deposits diffusing in which is diffused into it. This is n-type deposit. N-type deposit. Then a layer of silicon dioxide is grown over it. Okay. Silicon dioxide. So a layer of silicon dioxide is grown over it. This is the silicon dioxide layer. Then this layer is etched off from these two sides. Okay. And these two regions are exposed. Okay, right. Then what is the next step? Then you see, the wafer is then put into a furnace and trivalent atoms are diffused into the epitaxial layer. The trivalent atom change the exposed epitaxial layer from n-type semiconductors to p-type. That means, as we have drawn this diagram, you can see, we have taken p-type substrate. This is the base surfaces. Base substrate is p-type. Then we have deposited n-type material. Then silicon dioxide layer was grown and etched up from the both sides to expose the epitaxial layer. We have put this into a furnace and trivalent atoms are diffused into it, and as a result, from this portion, this n-type material converted to p-type. Now you see this portion of n-type converted into p-type. So we have got this figure here. You can see figure 2 of 1. So this part is p-types now, and this is n-type, and this is the silicon dioxide layer. Then again this here you see, pure oxygen is passed over the wafer to form a complete SO2 layer. Now this SO2 layer is completed, again passing oxygen over it. Okay, so we have got this now. You see this figure. So this SO2 layer is now completed. Again it is etched off to form an window. In the next step, it is etched off to form an window here. Then again what we have done in the next step, again now we pass trivalent atoms through the window. Okay, through this window trivalent atoms are passed. So we have got p-type region here within the n-type. Then again the silicon dioxide layer is completed using the same method as we did here, right? So then what we have done, after completing the silicon dioxide layer, so we have finally got p-n junction diode formed on the substrate, right? So this is nothing but p-n junction diode, and the last step is here. Let me show you the last one. The 13th step is here. Attach the terminals. We have to put the terminals at one at p and another at n. Okay. So for this purpose, we etch the silicon dioxide layer at the desired location. So where you have to put these terminals, from that portion only we have to etch the silicon dioxide layer, and as a result we have got the p-n junction diode, right? Now let's move on to next question. Next question, to convert this binary number into octal number system. So now you see octal and binary. So first let me write the given and group the numbers into 3 digits in a group of 3 digits. That means on the left hand side of the decimal, start grouping from the right hand side. Okay, from this side, and on the right hand side of the decimal, start grouping from left side. Okay. In octal system we have 8 digits: 0, 1, 2, 3, 4, 5, 6, 7. 0 to 7 there are 8 digits, right? And in binary there are only 2 digits. So first one, for 0 we can write 0 0 0. For 1, if you add 1 then you will get 0 0 1, right? And for 2, if you add one more 1, then 1 plus 1 10 in binary system, right? Then again if you add 1, then 3 will be equal to 0 1 1. Again if you add 1 here, then 1 plus 1, that's gonna be 10. Again carry 1, 1 plus 1 10, that's gonna be 100, right? So again this 4 becomes 100. Then again keep adding 1, then you're gonna get the next digit 1 1 0. Then the last one is 111. Okay, so we have got this. So if you see the table, so this is 100, right? This is 100. So where is the 100? This one. So replace this by 4, right? Then replace this by 111 is 7 here, so that's gonna be 7. Then replace this 101 101. Where is 101? This is 101 by 2. Then decimal, they can convert this 101. So this is 101, that is 5, this, right? And 010, again this is 2, right? But in exam don't show this way. Just let me show you the proper way to write the answer. Just cut it, right? This is equal to what you have got. 100 is equal to, this is 4. Then 111, that's gonna be 7. 010, that's gonna be 010, that is 2, right? Then after decimal we have 101, so which is again 5. Then 010, which is again 2, right? So therefore this given number, so let me copy this given number, which is in binary system, that gonna be is equal to 472.52 in octal system, right? Where base is 8. So this is your answer. And there is another method to solve this. That is what, just you need to first you have taken suppose 101, this number 101, just write here 421. Okay, cancel those numbers below which we have 0. We have 0 below 2 and 1, so cut these 2, then take 4. This is 4. Okay, then next group is 111. So now write here again 421. So here we have no 0 below any of these 3 numbers, so you will have to take all the 3 numbers. 4 plus 2 plus 1, that's gonna be equal to 7. So here it is 7. And again the next one is your 101, sorry 010. So again write 421, cancel the numbers below which we have 0, then we have 2 only, so this is 2, right? And again we have 101, then write 421. Here cancel the digit below which we have 0, then we have got 41. So 4 plus 1, that is equal to 5, right? Then again 010, and right here again 421, right here 421, and cancel the digits below which we have 0, then we have 2 only, so this is 2, right? That's how we can obtain this number, right? Hope you have understood this. Now let's move on to the next question. Describe how NOR gate can be constructed using diodes and transistor. Explain their action with truth table. So here you see, this is the answer. I have explained everything here. So now let me explain with the help of diagram and the truth table. So here you can see these 2 diodes, D1 and D2. So here these parts, you see these 2 represents cathode, and they are connected to the earthing, right? That means they are at lower potential. When you give voltage here, when it will be at a higher potential, that means our input will be input will be 1. When there will be no potential, then input will be 0. And here we're gonna get the output, this V0, okay, and this is VCC, and the meaning of VCC is voltage at common collector, okay, and this is the base of the transistor, okay, and this is the emitter. This is the emitter of the transistor. So you know these things. So here you see, when you give input 1 here, and here also 1, 1, then so that means you are giving signal to this base of the transistor, that will be again 1, but in that case this transistor will be on, and hence this all current coming from this potential will be grounded, as it is connected to the earthing, and hence we are not going to get any result, so output will be 0, okay. So in case of here you see, if you give anyone either A or B, any one of this on, that means here you are giving voltage 1, here the input is 1, this input is 0, 1 and 0, or this is 0, this is 1, in that case also, okay. This diode will conduct, if you are giving 1 here, this will conduct current to the base of the transistor. If this diode conduct current to the base of the base of the transistor, then it will be on, okay, and in that case then all current from this VCC will be grounded, so we are going to get output 0, 0. So when you when your inputs in both A and B are 0, then there will be no current to the base of the transistor, and transistor is now off. In that case, the current coming from this VCC will go to this end instead of grounded, okay. Now as this transistor is off, so this connection is cut off to the ground, so that's why we're going to get output 1. This is the truth table of NOR gate, right? That's how, using 2 diodes and a transistor, we can construct NOR gate, okay. So take a screenshot of this. Let me just wait, let me clean this things so that you can take a screenshot of this, and just, so here this is the diode, you can see, let me make it darker. This is B, this is A, and this is VCC, and this is V0, okay. This is the transistor, emitter of the transistor, right? This is collector, and this is base of the transistor, and this is grounded, okay. There is a resistance, this is the resistance. So now take a screenshot of this. So this is your answer. So remaining questions will be solved in the next lectures, okay. So stay connected and hit the bell icon so that you get notified when new video will be uploaded, and please hit the thumbs up button, and also do subscribe the channel and share with your friends. So thank you for watching. See you in the next video.